February 20th, 1943, Kasserine Pass, Tunisia. German tank commanders watched in disbelief. Through the dust and chaos of the North African battlefield, a small formation of American Sherman tanks was executing maneuvers that simply shouldn't have been possible. 5 Shermans, separated by broken terrain with no line of sight between them, converged on German positions with supernatural timing. No flags, no flares. They moved as a single organism. The German tankers, in their formidable Panzer IVs, struggled to hear their own commanders through a constant, overwhelming static. What they didn't know was that the most decisive technological advantage of World War II was revealing itself, not in armor thickness or gun caliber, but in invisible electromagnetic waves. While German forces relied on radio tactics pioneered in the 1930s, American engineers at Galvin Manufacturing, later known as Motorola, were perfecting something new: frequency modulation, or FM technology. The U.S. Army standardized the SCR-508 radio set, which was revolutionary. The American system was a technological leap. It delivered crystal-controlled precision with 25 watts of transmission power, 2.5 times the output of the German Few G5. Most critically, FM technology, originally developed by Edwin Armstrong, eliminated the static and interference that plagued the German amplitude modulation (AM) systems. Even during artillery barrages, American crews enjoyed crystal-clear voice communication. The American radio system, weighing 181 pounds, turned every Sherman into a node in the world's first battlefield network. The dual receivers allowed commanders to monitor their platoon and company channels simultaneously. Furthermore, the integration with the BC-606 intercom meant all crew members could instantly alert the commander to threats. The German system, by contrast, was built on a rigid, outdated hierarchy. A standard 5-tank German platoon included only 1 or 2 vehicles with full transmitting radios. The rest carried only receivers, meaning they could hear orders but could not respond or report enemy positions. German Few G5 radios, operating on AM, had a fundamental limitation. Their 10-watt transmitter struggled to reach more than a few hundred meters when tanks were moving. Every spark plug, every motor, every track movement generated interference that crippled the AM signal. When a German command tank was destroyed, easily identified by its extra antennas, the entire platoon often lost coordination. Adding to the crisis, German industrial production failed to meet the communication demands of their own doctrine. By 1943, Germany manufactured approximately 5,700 medium tanks, but fewer than 2,000 FUG transceivers. While the Soviet Union struggled to equip 25% of its tanks with any radio, America achieved a 100% deployment of sophisticated FM systems in all 49,324 Sherman tanks. The tactical advantages were undeniable. In Italy, the mountainous terrain should have favored the German defenders, but the SCR-508's FM technology excelled in multipath interference, allowing American tanks to coordinate movements where German AM radios failed completely. American forces could create ad hoc battle groups, adapting instantly, a flexibility that completely baffled German commanders. The Battle of Aricourt in September 1944 perfectly illustrates this. Facing superior German Panther tanks, the 4th Armored Division's radio coordination proved decisive. Tanks instantly reported enemy positions, and devastating artillery strikes were called in within minutes. In 3 weeks, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans, achieving a staggering 7.1 kill ratio, a victory that defied the technical specifications of their respective tanks. Later in the war, the capture of the Remagen Bridge demonstrated the speed of the American command structure. When the 9th Armored Division found the Ludendorff Bridge intact, the radio report reached 1st Army headquarters within minutes. German counterattacks, poorly coordinated due to collapsed communications, arrived piecemeal and were systematically destroyed. Throughout the war, German intelligence fundamentally failed to grasp the significance of the SCR-508. They attributed American coordination to extensive training and rigid communication procedures, completely missing the technological foundation. They continued to target supposed command tanks, not realizing that every Sherman could coordinate battlefield responses. American crews fought with the knowledge they were never alone, remaining connected even when isolated. German crews experienced the opposite: profound isolation. After the war, U.S. technical intelligence confirmed the communication gap. German equipment was approximately 5 years behind American systems. The victory of the Sherman tank wasn't about its 75-millimeter gun or its sloped armor. It was about the 181 pounds of radio equipment that turned it into a component of a unified weapon system. The words, whether accurately quoted or apocryphal, of Field Marshal Wilhelm Keitel at Germany's surrender, captured the fundamental truth. We knew how to build better tanks, but you knew how to make them work together. The SCR 508 established the principle that governs modern warfare. The network would defeat the platform. The ability to coordinate, to share information instantly, proved more powerful than the armor-piercing rounds of the mighty German 88mm gun. This invisible advantage changed warfare forever.